Okay, so we're going to do rectangles, and rectangles build on parallelograms, and they build on, well, no, they just build on parallelograms. They still have 360 degrees on the inside, but they have some very unique characteristics. So we know about a rectangle. This side and this side are the same. So if this bottom length is 27, so is the top. And we're used to the rectangle being called length and width. That means you have two sets of equal sides. Those sides that are equal are going to be parallel to each other. So these two will never touch, they're the same. These two will never touch, they're the same. Something new is the diagonals are equal. So that means if AE, that little piece, is 15, I know because the way of a diagonal works, it's cut in half. That piece is the same as this piece, so that's also 15. But because these diagonals are the same, that means every little segment here is 15. So if I go through and I fill out AC, I know AC is made up of two pieces of 15, so 15 plus 15, that gives me 30. Then I know BD, same thing. 15 plus 15 gives me 30. Also, if I know one diagonal, I automatically know the other. Then I have BE. I know BE is half of a diagonal, so that's 15. Then I have AB. AB is that top length. Well, I know both of the parallel pieces are the same, so this is 27. And then lastly, I have BC. Now for BC, I'm going to outline part of it so you can see kind of what we're talking about. In this rectangle, like when we were talking about interior and exterior angles, it is made up of two different triangles. Those two triangles are both right triangles. So because these are both right triangles, here's my right angle. I have a bottom, or A, of 27, and I have my C, or my hypotenuse, of 30. That means if I were to redraw it here, I can figure out BC because I know two pieces of the right triangle, and I'm just going to subtract to get the other. When I say subtract, that means underneath my square root sign, it's c squared minus a squared, so that's 30 squared minus 27 squared. If I were to get my calculator, oops, let's go to calculator screen. In my calculator, here's my square root, 30 squared minus 27 squared. That gives me 13.1 if I were to round it to the nearest whole number. So because that piece is 13.1, BC is 13.1. So now if I go look at the angles in a rectangle bring us back to a couple of units ago. A couple of units ago, like unit 4, when we did alternate interior angles, there was a pattern. If you had two sets of parallel lines, or two parallel lines, the opposite sides of those parallel lines were congruent. So that means where I put those two dots, those are going to be the same amount. Oh, I know that's 27 degrees because the other side is 27 degrees. Something else that a rectangle has is two sets of isosceles triangles. Remember, isosceles triangles have two of the same sides. That's important because if it's an isosceles triangle, that means these two bottom angles are the same. So where I put those two small dots, those are also 27. Where I put these small triangles, those are also going to be whatever that other angle is. So we kind of have a pattern here. It's either one number or the other, depending on where it pops up, either on my parallel line or my transversal, or where in my triangle. So if we look back at this one before, this angle in the corner was a 90-degree angle. So in order to figure out this triangle, that's just 90 minus 27. 90 minus 27 gives me 63. So that means everywhere I see that triangle, it is 63 degrees. Now I'm going to come in and I'm going to look at my three angle letters. MJK, if I trace that with my finger, that's MJK. That is this whole upper angle, so that's 90 degrees. Then I have MJL, that's the triangle, so that's 63 degrees. Then I have JLK, that's another triangle, that's actually where that arrow is pointing, so that's 63 degrees. And then I have KML, that's where my little dot is, that's 27 degrees. And then lastly I have MNL, that's this angle in the middle. This angle in the middle, in order to figure out, I'm going to subtract the 2 I know, which is these two 27s, from 180. That gives me 126. Okay, so looking at this next problem mixes both 1 and 2 together. It was angles and sides. So it says given DB, that's this whole diagonal, it's 42. And AD, that's this width side, it's 26. That means I automatically know the opposite side is 26 and the other diagonal is 42. I also know that because the whole diagonal is 42, if I divide that by 2, all of these little half diagonal pieces are 21. And then it says DAE. If I follow that, that's DAE. That's here where my circle is 52 degrees. So that's my given. That's my given. That's what I know just from looking at it. I know my parts of my diagonal because I have the whole diagonal, and I know both diagonals are the same. I have my widths because the widths are the same. So let's go through and see what we have. We have AC. Well, that's the whole diagonal. Got it. We have EB. That's a half diagonal. So we got it. I have BC, that's the other width, so I got it. Then my last one is AB. AB is my length. I don't know my length, but I have a right triangle, so if I draw it out, there's my right angle. I know the diagonal here is 42, and my short piece was 26. So I'm going to do the same thing as in number 1. I'm going to take the square root, 42 squared minus 26 squared. So in my calculator, I'm going to do the same thing. 46 squared minus 26 squared. Oops, 42, not 46. That gives me 32.9. I'm going to round that to 33 just because it's right there. So that means AB is 33. Now I can focus on my angles. First angle is ADC. Well, I'm going to go through and I'm going to make my pattern like I did here. I need 2 shapes. So I've already set a circle. So these are circles, because opposite sides of my diagonal, also same side, same triangle. Then I'm going to make my other shape, we're going to make it a rectangle. How about that? Rectangle and a rectangle. So there's my rectangles. Now I have 2 options. Dots are going to be 52. Rectangles are going to be whatever 90 minus 52 is. So let's go see. I have ADC, that's a dot, or a circle, so that's 52 degrees. Then I have ABD, that's a rectangle, so that's whatever 90 minus 52 is. 90 minus 52 is 38, so that's 38 degrees. Then I have BCA, that's a dot, so that's 52. Then my last one is DEC. They're always going to give you 1 in the middle, because why not? These 2 are rectangles. Rectangles are 38, so that's 38 and 38. So to figure out this missing one, that's 180 minus 38 minus 38, which gives me 104 degrees. So those are just kind of my basics, my basic side patterns, my basic angles. So now let's look getting more into adding algebra into it. So for number 4, it says find EF, given that I have 2 lengths. Well, I know in a rectangle that the 2 parallel sides, or the 2 lengths, are the same as each other, so I'm going to set them equal to each other, and then I'm going to solve. If I set these equal, same 3 steps that we always do when we're doing these. I'm going to subtract my x to the left, I'm going to add my constant to the right, and then I'm going to divide whatever's in front of x by what I have at the end. So subtract my x to the left, add my constant to the right, simplify what all of that is. That's 4x equals 44. Then to find x, I'm going to divide by whatever's in front, which gives me an x of 11. Now I want EF, but realistically it doesn't matter which one of these you plug into, because EF, we just said, was the same as CD. So 7 times 11 minus 39. That gives me an EF of 38. This is a side length, so no degrees, just a side. Now let's look at number 5. In number 5, it says if RT, that's a full diagonal, is 5x minus 14, and US, that's the other full diagonal, is 2x plus 10, find VT. That's a half. I'm just going to make a note right there that it's a half. So if I find the full diagonal, I need to set them equal to each other. So same steps as before. Work through this one quickly. Same steps as before, move your letters to the left, constants to the right, divide whatever is left by whatever's in front of x, so that gives me an x value of 8. Now I need VT, so I'm going to plug it in right here to RT. So I know RT is 5 times 8 minus 14. 5 times 8 minus 14 gives me 26, so RT is 26. But I just said VT was half of that, so I'm going to divide 26 by 2, and that gives me a 13. If you need the whole, stop at the 26. If you need half, go through and divide. Now for number 6, if I were to make my angle patterns, I know that angles on opposite side of the diagonals are equal to each other. So before it asks me to do anything, I know I need to find x because I can't have letters in what I have at the end. So I'm just going to take these two expressions and set them equal to each other. There is 11x minus 3 is equal to 7x plus 5. Pause the video, take a second, see if you can figure out x. Then restart and see if you're right. So when I move everything around, subtract my 7x, add my 3, that gives me 4x equals 8, so that gives me an x value of 2. Now I need to see what it's asking. It says find BCE. Well, BCE is this angle where my blue dot is. Kind of hard to tell that that's blue on the camera, but whatever. Trust me. So if that's BCE, and I know this piece, because I can plug the 2 in and figure out what it is. If I substitute the 2 in, that's 11 times 2 minus 3, which is 19. I know that half is 19, and I know the corner angles in the rectangle are going to equal 90. I can figure out what BCE is by subtracting the given here, DCE, from 90. 90 minus 19 gives me 71 degrees. Now I have the rest of my pattern if I needed anything else. Now there's one last way that they can ask you to do this in rectangles, and that would be by putting these two next to each other. Like we just established in this last step to find BCE, if I have two angles in the corner, they're going to add to equal 90 degrees. That is a right angle. So that means I'm going to add these two and set them equal to 90. Now normally you're used to equaling them to 180. Please don't do that here because you will get the total wrong answer. If I set them equal to 90, then I'm right because that is a 90-degree angle. So my first step here is to combine my like terms. So I have 12 plus 3, which is 15x, negative 17 plus 2, which is negative 15, and then I still equal it to 90. Now to get it by itself, I'm going to add 15 to both sides, which gives me 105. 105 divided by 15 should give me 7 for my x value. Now I want JHI, so if I trace this JHI, that's this angle here. Because of the pattern of the angles of rectangles, the alternate interior angles on this parallel line transversal, I'm using this expression. I need the opposite side from where that dot is. So I'm going to plug that in. That's 3 times 7 plus 2, which gives me 16 degrees. Oh my goodness, that is definitely not how math works. 3 times 7 is 21. That should give me 23 degrees. Pardon my mistake. If you have any questions, please reach out and let me know. Thanks, guys.